Okay, so question number 2. How do the molecular geometries of the molecules iodine pentafluoride and phosphorus pentafluoride differ? Okay, so we have different options. So first, let's just draw out the Lewis structures for both of these molecules. So first, we'll focus on iodine pentafluoride. And to find out its Lewis structure, we need to calculate the total number of valence electrons in this molecule. So iodine has 7 valence electrons, and fluorine also has 7. And since we have 6 fluorine atoms, we multiply that by 6, and we get a total of 42 electrons. Okay, so now that we have the number of electrons, we can try to draw out a skeletal structure for this compound. So we can draw iodine with 5 fluorines that are single bonded and show all of the lone pairs. Okay, so if we count out how many electrons we have so far, and if we recall that each bond contains 2 bonding electrons, then we only have 40 electrons out of the 42. So I need to draw an additional pair of electrons on our iodine to give us the final Lewis structure. Okay, so now that we have the Lewis structure, let's look at our central iodine atom and see how many bonding pairs it has and lone pairs. So there's 1 lone pair on iodine, and we have 5 bonded atoms. So using a VSEPR chart, we can find out its molecular shape. Okay, so when a molecule has, on the next page, 1 lone pair and 5 bonded atoms, we get a square pyramid shape. Okay, so now let's do the same thing for phosphorus pentafluoride. Okay, so again, we need to calculate the total number of valence electrons. So phosphorus has 5, and fluorine has 7. And since there are 5 fluorine atoms, we multiply this by 5. And we get a total of 40 valence electrons. And now let's draw phosphorus as our central atom and the 5 bonds to the fluorines. And we'll also draw in all of the lone pairs. And if we count out how many electrons we have in this structure, you can see that we already have our 40 electrons in the structure. So again, we can analyze the central atom to figure out the molecular shape. So the phosphorus has 0 lone pairs, and it still has 5 bonded atoms. So if we refer to a Vesper theory chart, when there are 0 lone pairs and 5 bonded atoms, we have a trigonal bipyramid molecular shape. Okay, so now let's see the options that they give us in the question. So in part A, in iodine pentafluoride, there's a lone pair of electrons on iodine. Yep, that's correct. Whereas in phosphorus pentafluoride, there are no lone pairs on phosphorus. As a result, the molecular shape of iodine pentafluoride is square pyramid. Yep, and phosphorus pentafluoride is trigonal bipyramid. Okay, so that's already just option A is our correct answer. And if we double check and look at options B and C, you can see that we don't have a lone pair on phosphorus, so we know this is incorrect. And we know that C is incorrect because the iodine pentafluoride isn't octahedral. We have an octahedral shape when we have 6 bonded atoms and 0 lone pairs. Okay, so the junior tutor said for step 1, list the elements, their valence electrons, and determine the total valence electrons. If a charge is present, add the value of the charge to the total valence electrons when it is negative, and subtract if it is a positive charge. So they got 42 and 40 for our 2 compounds. So now they have the skeletal structure for both of them, and they distributed the remaining valence electrons for the 2 compounds. And you can see the lone pair on the iodine. And for step 4, determine the steric number by adding the lone pairs in the central atom and the number of bonds in the central atom is involved in. Okay, so we kind of did the same thing. And they have a table, a Vesper table, that identifies the molecular shape. Okay, so they got square pyramid and trigonal bipyramid, so the correct answer is A. So this solution is correct.